Let us consider some of the select challenges of artificial intelligence, some of the occasions where artificial intelligence is problematic, doesn't work properly, does lead to ethical challenges. Well, the first thing I would point out as an example is the topic of deepfakes. Deepfakes are seemingly realistic videos generated by artificial intelligence. They had a level of quality which you couldn't generate, couldn't fake without artificial intelligence. They were first seen on Reddit with pornographic videos doctored to feature the faces of female celebrities, but then there are many more examples. And if you haven't seen deepfakes so far, or if you want to learn a little more about it, I recommend you watch this short video here, which we link here. It provides you examples from Barack Obama, Kim Kardashian, Arnold Schwarzenegger, Adele, and others. And it discusses on how alarmed we should be about deepfakes and how they relate to other types of fakes. But that should be it on deepfakes. That's one of the problems, one of the challenges of artificial intelligence. Another one is incorrect translations. Here we have an example from a tweet which Emmanuel Macron posted after his 2017 election victory. And this tweet was in French. It was translated automatically by Microsoft. And to the American English, it was translated as "my fellow Americans." Well, definitely Emmanuel Macron didn't talk about his fellow Americans, but about his fellow Frenchmen and French women. But then the problem here is that machine learning doesn't know causalities, it knows only frequencies. The machine doesn't know what is right, just how something has been used so far. And when politicians address the people in English, they often mean fellow Americans. So basically this translation algorithm was trained on texts from many politicians who said fellow Americans, because many English texts are from Americans, from American politicians. So that was the corpus of text the algorithm was trained on. And so it thought if somebody like Macron addresses his fellow citizens, then he likely means his fellow Americans. Now here you can say, well, that's a pretty easy and unimportant mistake. But if you think about the general pattern behind that, then the problem there is that the machine doesn't understand the context, doesn't understand the causalities or anything. It only understands training data and how to map this training data on the current instance it sees here on the text. And if the training data was biased, for example, by addressing citizens as fellow Americans, then the output of the algorithm is biased. And here it's rather easy to spot that Emmanuel Macron likely doesn't say that. In other examples, it might be way more difficult to spot that. Apple and also Goldman Sachs came under fire because they had an algorithm which was responsible for deciding on customers' credit lines. And this algorithm appeared to be illegally discriminate against women. And what was the problem here? It's basically the same as with this tweet from Emmanuel Macron. Machine learning algorithms are characterized by the search for latent variables and interrelations. So they are characterized by the search for things which are not directly observable, which they learn and then represent in the learned model. And it is possible that a model is able to infer gender through a single variable or a combination of included variables in the credit application. And even if I don't assume that it was the intention of Apple and Goldman Sachs to discriminate against women, then the machine learning algorithm learned to do so because it probably learned that in historic data, women were less able to repay their debt. So they decided negatively against the credit card applications, the credit lines by women, and probably not from a field which indicated the gender as male, female, or other or so, but because it picked up subtle differences in the credit card applications. For example, the names of schools or the typical courses of studies where we have gender imbalances or the like. And an additional problem here is that the historical bias may have influenced the algorithm's decision. As recently as in the 1970s, women in the US could be denied credit cards if they did not have a man to co-sign on the credit card application. And now this is speculation, it's not publicly known whether that's true or not, but a likely speculation is that such old training data went into the set of training data used here for this machine learning algorithm, and then this old training data biased against women, and this bias carried over to current credit card applications. So again, it's the same problem as we've seen before with the tweet, with the wrong translation of the tweet. If you have biased training data, then you will have a biased model and it will lead to biased results. And it's difficult to spot these biases because the training data is so huge, it's so unoverseeable that you don't really know whether it's biased in many occasions. And then it's difficult to foresee that this bias will enter the algorithm. But nevertheless, as a developer of such system, as a trainer of such a machine learning model, you have the responsibility to care for such biases and to prevent such biases, because you shouldn't discriminate against people and you shouldn't do illegal things. Now here's another example, an error with Google's automated image tagging. So you see many correct tags on the upper left image. These are skyscrapers, airplanes, cars, bikes, but at the lower line in the middle, these are not gorillas, these are people. But now the automated image tagging algorithm by Google made this mistake, and obviously they got a big public outcry on this and they apologized for it. But the problem is, if you have biased training data, and for example face recognition data used to be trained on rather images from Caucasians with rather light skin color, then the performance might be good there, but the performance might be worse in other situations, for example, for people of color. And now the question I would pose to you is, how can such incidents be prevented? What could one do, and who should do that to prevent that such things happen in the first place and you don't have to apologize in the aftermath? So let's continue with two further examples going in the same direction to show you the breadth of the problem. Another example from Google, automated discrimination in the labor market. It turned out that the ads Google provides you by the side of your search results, if you search, for example, for jobs, then there are job advertisements. And the job advertisements shown to men used to be for substantially higher paying jobs than job advertisements typically shown to women. Is Google to blame for that? Well, that's a good question, whether they should have known that in advance and prevent that. I can understand how that happens. If you look at the reality in the labor market, then in many areas it's the case that men have the higher paying jobs than women have. We have a gender pay gap in reality. And likely we also have a gap in which job advertisements men or women react to. So I can understand how the algorithm picked up that there might be a gender pay gap and then decided to show higher paying job advertisements to men and lower paying job advertisements to women. But nevertheless, even if I say I can understand it, it's not right to do so. It's a problem. And this was discovered by Patel and others in 2015. So it's already a long time ago. And I assume that this isn't the case anymore. But it shows you these subtleties these biases might have. And it shows you with the examples from Google, from Microsoft, there are others by Amazon, by Apple and so on, that even these companies who are pretty advanced in developing and applying artificial intelligence fall prey to these problems. So it's a widespread problem. It's not easy to tackle that. So another example. In the US court system, there's something which is called recidivism scores. So if the question is whether a judge should send someone on parole or keep her or him in prison, then there might be an algorithm which calculates the score from 0 to 10, which tells you the likelihood of recidivism. So how likely is this person to commit another crime once sent on parole? And if you want to learn a lot about it, visit the website of Publica, who are very deep into investigating that. Here in this example, they compare two people, the guy on the left-hand side, the woman on the right-hand side, and they get a very different score here from the compass system. So it's called compass score here. So the man gets a 3, very low score, the woman a 8, a high score. And now if you go to ProPublica's website, you can find many examples and you can read through the cases on what the prior deeds of these people were, how it turned out later on after they were released, whether they committed other crimes or not or so. And they have many examples which they demonstrate that very likely these scores are discriminating, racially discriminating, for example. And these scores, a problem with them is they are trade secret of the for-profit firms supplying these. So there's a judge, he gets this prediction, this person is very likely to commit other crimes if you don't keep him in prison. This person is not very likely to commit other crimes. And it's still up to the decision of the judge whether to send someone on parole or in prison. But it's reasonable to assume that these scores have an influence on that decision. And that a judge seeing a high prediction from an algorithm that somebody will commit further crimes will be more likely to send the person back to prison, and with a low score will be more likely to release the person. So these algorithms have an effect on these very important decisions. And they are not inspectable, they are not auditable, they are trade secrets by for-profit companies, and they neither disclose the workings of the algorithms nor the exact data which goes in there. But it's very likely that many different data points go in there which allow for discrimination, even illegal discrimination, for example racial discrimination, which shouldn't be the case. So that's one of the more troubling applications of these biases, but all the other biases I showed you are also troubling. And the general problem with that is that database predictions and reality are mutually dependent. As a closing slide, I want to illustrate that a little more. You have input data, which you feed to a machine learning algorithm. This input data in the examples I showed you here is labeled input data for a supervised machine learning algorithm. And the supervised machine learning algorithm is often not public. I just talked about these providers of these recidivism scores for the judges, but the same holds true for Apple and Goldman Sachs and the credit line decisions, for Google in the image tagging and so on. These algorithms are typically kept private. They learn from the input data and then they generate output which affects the world. And then this output feeds back into the input, because from that you prolong, for example, biases. If you have an HR system, a recruiting system, which sorts through the CVs of applicants and suggests whom to invite for a job talk and whom not, and it discriminates against women, as a system which was used by Amazon once did, well, then only men are invited to job interviews, only they are hired, only they are promoted, and then that feeds back into the database of the algorithm learning that this probably was the right behavior because women don't make career in that setting because they are sorted out in the first place. So reality and algorithm are mutually dependent here. And with that, discrimination carries over into the future without us actively programming it. I don't say that in any of the cases I described here, any programmer did these by purpose, programs this in by purpose, trains it by purpose, or so on. But with these black box machine learning models, which we can't fully inspect, at least not yet, we don't have the techniques for doing that yet. We don't really know what they learn and how they behave after learning. And so simply because the algorithm learns from distorted, bad, discriminatory, biased data, it learns through statistics and it is not able to question the content of the data. So there we get into many problems which require human judgment and human oversight. So these were starting with deepfakes and then talking a lot about biases, some of the select challenges which you face and which we as society face in applying more and more machine learning algorithms. But nevertheless, please don't take me wrong, I don't want to talk only about the downsides of machine learning. It holds great promises, it improves our economy, our society, our lives in many respects. But nevertheless, we need to keep these downsides and many more downsides, which I didn't talk about in this video, in our minds and see that we prevent them for really getting into a bright future with all the possibilities which machine learning and artificial intelligence in general offer to us.